Assalamu alaikum. So we are starting our today's class. In the last couple of sessions, we have discussed how to discuss the formulas for arithmetic progressions and also geometric progressions, right? So we know the term formula for an AP, the sum formulas for AP. There are two of them. We have discussed how to use those formulas in different situations and also talked about some more details. Then we talked about geometric progression in the next session after that, in which we discussed how a geometric progression is defined. First of all, the ratio is constant in this case, and we also covered the term formula and the sum formula for a GP. All right, there's one thing that's left here, that is sum to infinity of a GP. We will do that in the next class. Today, we are going to do some practice questions based on the concepts that we have done already. All right. So we also talked about this, that percentage increase or decrease. This is whenever you have a percentage increase over a number of values, the same percentage increase or a percentage decrease, those values can be considered to be in a GP. All right, geometric progression, and that's how we find the ratio for that. We discussed this. We also covered some more details apart from that. Now, the focus of today's session is going to be on doing some practice questions. So let's start with that. Now, let me just copy the formulas that you have for arithmetic and geometric progressions that are given in the formula sheet. Let me just copy them here. You will keep them in front whenever you are doing problems involving arithmetic and geometric progressions. So you're going to keep those formulas in front of you. All right, so let me just copy that from somewhere here, if I can find them. So you'll keep them in front. Okay, so these are the formulas that we have. They're given in the formula sheet. You need to be able to use them. All right. Now, we haven't yet covered the sum to infinity formula, but we've done the rest of them. All right. We'll do that in the next class, inshallah. Now, the problem says find the sum of the first 10 terms of the GP 81, 54, 36. So we know that it's a GP, it's a geometric progression. In the first part, we are given that it's a geometric progression. Let's write that down here. So it's a GP, first of all. And in this GP, what do we know? Remember, a GP was defined by the first term and the common ratio. The first term is 81. That's pretty obvious. What about the common ratio? For ratio, you basically consider any two consecutive terms. So if you consider, for instance, 81 and 54, divide the next term by the previous term. So whatever comes later, you divide that by whatever is coming first. So the ratio could be 54 over 81 in this case. If you simplify this turns out to be 2 over 3. Now, since 2 over 3 is not an exact decimal, it will be 0.6666 and then many sixes. It's better to keep it as a fraction. Otherwise, our answers might not be very accurate. All right, so keep it as a fraction. Don't convert it to decimals at this point, at least. All right, so that's the ratio. Now, what are we looking for? We're looking for the sum of the first 10 terms of this GP. So remember, we're talking about a geometric progression. How do you find sum of a certain number of terms of a GP? This is the formula that we've got for that. Sn equals a into 1 minus r raised to power n divided by 1 minus r. We just input values in this formula and see what we get from that. Now, since we are looking for sum of the first 10 terms, the value of n, therefore, is going to be 10. On the right side, we have a is 81, into 1 minus r raised to power n. So that's going to be 1 minus r, which is 2 over 3, raised to power n. Remember, the value of n is 10 here, divided by 1 minus r, which is 1 minus 2 over 3. This is how this fraction looks like. All right, now you could either put this whole thing, in your calculator like this, or you could do it step by step by first evaluating the numerator and then the denominator. That's your choice. So you could either evaluate them one by one or directly. How would you put these values in your calculator directly? Make sure that you're using the fraction button. All right. Don't rely on brackets because it ends up being very prone to errors. I would recommend that you use the fraction button properly. And then you can just input this directly in your calculator. That's going to give you the result. All right. So this turns out to be, just confirm, this is 238.8. That's the sum of the first 10 terms of this GP. That's what we had to figure out. All right. Let's look at the second part now. Now the second part says, find the sum of all the terms in the arithmetic progression 180, 75, 170, and we know what the last term is. That's 25. All right. So now it's an AP. We have an arithmetic progression, and the values that we have are 180, 175, 170, and we know the sequence ends when the value becomes 25. All right. Now let's write down the parameters that we have for this AP. We know that the first term is 180. What about the difference? We take any two consecutive terms, subtract the previous term from the next term. So it's going to be 175 minus 80. So be careful about this. The difference is going to turn out to be negative here. Don't just subtract 180 and 175 directly, like 180 minus 175. That would be wrong. You basically do next term minus the previous term, and that gives you minus 5 here. This is what the difference is. All right, so we have the first term and we have the difference. Now we use the sum formula for the GP. Now we have two formulas. No, in fact, this is an AP. So for an AP, we have two formulas, right? For sum, you have this formula and you have this formula. All right. Now, since we know what the last term is, we know that the last term is 25. It's going to be easier if we use the first formula, right? Remember, we used to use the first formula only when the last term was known. Now, remember, last term is the same thing as saying the nth term. We're talking about the nth term here. So if there are n values, there are n values in the sequence, the nth term is 25. That's what we're given. But the problem is we don't know what the value of n is in this formula. So we know the value of a, the first term, we know the last term, but we don't know what n is. And that's the case with the second formula as well. So you might think that you could use the second formula instead since you don't know n, but the second formula also requires the value of n. So there's no way to find the sum unless you first know the value of n. All right. So how do you figure out the value of n? You can think of it like this. You can say, we have an AP. The first term is 180. The second term is 175. The third term is 170. And then the nth term is 25. Now, do we have the term formula for a GP that looks like this? It's given in the formula sheet as well. By the way, there's a different notation that they use in the formula sheet. You should be familiar with that. UN, that's the same thing as TN. All right, so you can use any of them. It doesn't really matter. It's just notation. So it's basically TN. All right. We have the term formula for a GP that looks like this: AR raised to power n minus 1. What we can do here is we can say, let's use the term formula Tn equals AR raised to power n minus 1. What's the value of A? A is 180. Okay, I'm sorry. I messed it up. I'm sorry about that. We are actually talking about arithmetic progression here. So you have to be very careful here that you might end up using the wrong formula sometimes. We are talking about an AP here, not a GP. So how did I realize? Because I figured out there's no ratio here. So we can't really use this formula. So it's an AP in fact. So you should be using this formula for that, right? That's the term formula for an AP. Let's use that. So let me just write that down here. Tn equals A plus n minus 1 times the difference. That's the formula. Now we know that the value of the nth term is what? 25. This is basically the value of Tn. So we can put T25 here. A is 180. n is unknown, you have to figure that out. -1 times the difference. The difference is -5. Make sure to put that in bracket like this. N -1, this whole thing comes in bracket. And -5 also comes in bracket like this. And let's simplify this. You get 25 equals 180 minus 5n plus 5. Take n to the left side. That gives you 5n equal to 180 plus 5, which is 185, minus 125, which is going to be 160. And the value of n turns out to be 160 over 5, which is 32. All right. This is the value of n that we get from this. So now that we have the value of n, what we can do is we can just input this value of n in the sum formula for an AP. We could use any of the formulas, it doesn't really matter. Well, it's going to be quicker if we use the formula that has the last term there. So it's half n, it's right here, into a plus l. And that's what we're using here. What do we get from this? We are looking for the sum of 32 terms. We put n equal to 32. That gives us half into 32 into a plus l. The first term is 180. The last term, the nth term here, is 25. You put that here. And now you just evaluate what this number turns out to be. And that will give you the result. All right, use the formula and see what you get. So this is giving me 3280, and that is the sum of these 32 terms. That's what we were looking for. Make sense? That's the second part of this question. We had to find the sum of all terms in that arithmetic progression. Okay, now let's look at another problem. Let's make this difficulty level slightly higher. Open the worksheet. Paper 1, AP, GP. Make sure that you are practicing questions from the worksheet as well. Let's try this question. Question number 31 from the worksheet. Let's try this. All right, again, if we want, we can copy the formulas here as well. It will make things easier. These are the formulas. Just copy them here. All right, so what are we supposed to do here? In the first part, it says, the first and last terms of an AP are 12 and 48 respectively. So the first and last terms are of an AP. So we're talking about an arithmetic progression here. It starts from 12, then we don't know the rest of the terms, and then you have 48 at the end. So the first term was 12. If there are n values in the sequence, the nth term would be 48. We can write it like this as well. You can say this is term 1, and this is term n. It says the sum of the first 4 terms is 57. Now, how do you write this in the sum formula? You can say S4, right? S4 as sum notation, sorry. What does S4 mean? S4 means sum of the first 4 terms of a sequence. How do you calculate that? This would be equal to 57. So it's given out actually. So it says the sum of the first 4 terms is 57. So we have one piece of information given here as well. It says find the number of terms in the progression. So we need to find the value of n using this. Now, how do we figure this out? So we have an AP for which we know the first term. The first term is 12. We know the sum of the first 4 terms, that is 57. We don't know the value of n, right? Now, keep in mind, this 48 is the last term of these n terms. If we were to consider n terms, 48 would be the last value amongst these n terms. All right. The sum that we're given here is for the first 4 terms only. Now, if you use the last term formula for sum, that would look like this: half into n into a plus L. Remember what L stood for here? L is essentially the nth term. If you put the value of n to be 4 on the right side, you would need the 4th term. We can't say that the 4th term is 48 because we do not know the value of this n. So don't be fooled by that. The last term that we're given here cannot be used here because it's something like this. For example, we don't know what the actual values are, but let's say there was some second term, then some third term, then some 4th term. We are given that the sum of these 4 terms is 57. So if you were to use this formula, the nth term would be this 4th term in this sequence. Now, we don't know whether that's 48 or not. So keep that in mind. We can't input 48 here. So what do we do instead? We can't use the last term formula because we do not know the last term. That means we do not know the 4th term of the sequence, right? We don't know the 4th term. If you had to use the last term formula, you would need to know the 4th term of the sequence. That is unknown. So what we do instead is we can use the other formula. What's the other formula like? It's half into n into 2a plus n minus 1 times the difference. Now, what we're looking for is the number of terms in the progression. So we're looking for the value of n here. So we have this formula, Sn equals half n into 2a plus n minus 1 times d. What's the sum that we're given? We're given S4. So we could say S4 is equal to half into 4 into 2 times a. The value of a is known, that's 12, plus n minus 1. N in this case is 4, right? 4 minus 1 times the difference. We don't know what the difference is. So we have an equation in which we have only one unknown, and that is d. We could find the value of d from this. So we can just cancel this out. You're left with 2 here. And then you have 2 into 24 plus 3d inside. Let's simplify this. That gives us 57 equals 48 plus 6d. 9 equals 6 times d. And the difference value turns out to be 1.5, which is 9 over 6. So now we know what the difference is. We know what the difference is, right? So we know that the difference value is 1.5. That's what we have figured out now using that sum that we were given. Now, since we're looking for the value of n here, what we can do is we can say, let's use the nth term formula. What's the nth term formula? That's Tn. So we're talking about an AP here. The term formula for an AP is a plus n minus 1 times the difference. We know that the value of the nth term is 48, so we could put 48 here. The first term is 12. We know the value of the difference as well. The difference is 1.5. You could solve this equation and you would figure out the value of n from this. So we get 48 equal to 12 plus 1.5 n minus 1.5. That gives you 1.5 n. You have 10.5 on this side. It goes to the other side, gets subtracted, and you're left with 37.5 there. N would turn out to be 25. 37.5 over 1.5, that's 25. And that is what we were looking for. We were looking for the value of n from this. Is that all right? So that's what we would do here. Let's look at the second part. Now it says, the third term of a GP is 4 times the first term. We're talking about part B now. The third term of a GP, so we're talking about a GP. So it's a GP. In this GP, they're saying The third term is 4 times the first term. So we could say T3, that's the third term, is 4 times the first term. T1, or we could use A for that. Remember, A represents the first term. So T3 is basically 4 times A. All right, that's what we are given. Now, the sum of the first 6 terms is K times the first term. Sum of the first 6 terms. What does that mean? That means S6, sum of the first 6 terms, that is equal to K times the first term. The first term is A, so it's K times A like this. All right, we have 2 equations now. We can just use the formulas, the term formula and the sum formula for a GP. The term formula for a GP is AR raised to power n minus 1. And for the sum formula for a GP, that is A into 1 minus R raised to power n divided by 1 minus R. This is what we are given in the formula sheet. All right. Now let's input values. So we're looking for T3 here. T3 would equal A into R. We don't know what the value of R is as well. So it's just AR raised to power 3 minus 1, which is 2. We know the value of T3, that is 4 times A. So we have 4A equals AR square. A and A get cancelled. Remember, because A cannot be 0. If A was 0, all the terms would be 0. It's a GP, right? So A cannot be 0. So we can cancel that out. A can be cancelled out. We are left with R square equal to 4. Now, R could be equal to plus minus 2 from this. There are 2 possible values of R that we get. Now, you're getting 2 values, so you might just have a look at the question in case there is any condition given for the ratio. It doesn't say anything about the ratio. In fact, you are asked about possible values of K. That means you are going to get multiple answers, right? So it's possible values of K. So multiple values of R are going to give you multiple values of K. So you consider both of these possibilities. R could be plus 2 or minus 2. Now, what's the sum formula? The sum formula is A into 1 minus R raised to power n. Sorry. We are looking for S6. That would be A into 1 minus R raised to power n over 1 minus R. The value of n is 6. We can just replace that with 6 here. Now, since it's equal to K times A, we can put S6 equal to KA here. All right, so in place of S6, we can write K times A. Now, A and A get cancelled. What are we left with? We're left with K equal to 1 minus R raised to power 6 divided by 1 minus R. That's the value of K. We are looking for the possible values of K. We have 2 values of R. What we can do is we can once input R equals 2 in this, and once we can input R equals minus 2 in this. And that's going to give us 2 possible values of K. If we input R equals 2, that gives us K equal to 1 minus 2 raised to power 6 divided by 1 minus 2. And that's going to give us minus 63 in the numerator divided by minus 1, which is 63. This is one possible value of K. The second value of R is negative, so we have to be careful. When we input that here, we have to put that whole thing in brackets. Minus 2 whole raised to power 6 divided by 1 minus minus 2. All right. Now in the numerator, we get 1 minus 64 because an even power becomes positive. In the denominator, we have 1 plus 2, which is 3. And that gives us minus 63 over 3, which turns out to be minus 21. This is the second value of K that we get from this. All right, so these are the 2 possible values of K that we have as the answers from part B. All right, let's look at the next problem now. Let's look at one more. Okay, let's try 32. This is question number 32 from the worksheet. Now, this has an important concept that you need to know about. Question number 32. All right, so it says, in an arithmetic progression in an AP, the sum Sn of the first n terms is given by Sn equals this. All right, now let me just copy the formulas here. This is what the formulas look like. So we're talking about an AP in the first part. We have an arithmetic progression. In this arithmetic progression, we are given that Sn, the sum of the first n terms, that is equal to 2n square plus 8 times n. Find the first term and the common difference of the progression. Find the first term and the common difference. Now, there are two ways of thinking about this. One idea is that we find our own sum to the n terms. That's one idea. So you could, for instance, use this AP formula, because the formula that they're giving, it does not have the last term. And in fact, you are not supposed to find the last term. You're only supposed to find the common difference and the first term. That those two things come in the second formula. So what you can do here is, one idea is you write down your own formula. That's half into n into 2 times a plus n minus 1 times the difference. This is the sum formula for an AP. All right. Now, this is the formula that they have given, and this is the formula that we have. What that means is they should be identical to each other. The formula that they have given and the formula that we have, they need to be identical because they're the same formula, right? It should be just one way of writing. It should be just another way of writing the same thing. So what we can do is we can just simplify this expression. Simplify this expression such that we have an n square term and we have an n term, and then we can compare the two formulas. All right, let's try that. Let's simplify this. Half n into 2a, that is going to give us a times n. Then half n into that thing, that's half n into dn minus d. All right, so I've just simplified this thing. That's dn minus d. Let's simplify this further. It becomes an plus half dn square and then minus half dn. Now we need an n square term and an n term. So you can bring the n square terms together. There's only one of them. So that's half dn square. And write the n terms together. There are two of them. What's the coefficient of n? You can take n common, and that leaves you with a minus half d inside. This is the formula that you are getting. All right, so there's a formula that they have given, and the formula that you are getting is half dn square plus a minus half times d. No, sorry, a minus half d times n. All right. Now, since they represent the same thing, they are supposed to be identical. What we can say is the coefficients of n square should be equal, and the coefficient of n should be also equal. So we can say half d should equal 2 here, and a minus half d, this thing should equal 8. So we get two equations from this. We have half d equal to 2, and we have a minus half d equal to 8. We are comparing the coefficients of n square and n here. What do we get from this? From the first equation, we're getting d equals 4. Now, once you have the value of d, all you have to do is input this in the other equation now. And that becomes a minus half into 4 equals 8, and that gives you A equal to 10. And these were the two values that we were looking for. The value of the first term and the common difference. The first term turns out to be 10, and the difference is 4. This is one idea. All right. You should know about this idea because you will need to use this sometimes. That if you're given a formula in the question already, and you have that formula given in the formula sheet as well, you can just simplify the one that's given in the formula sheet, compare the two, and you'll find the values of unknowns from that. All right. Another idea here could be, which is going to be easier in this case, that you know the Sn formula, right? That is 2n square plus 8n, and we know it's an AP, it's an arithmetic progression. We could find S1 from this, right? So this is the general formula that gives us Sn for any value of n. So we could find S1, for instance. What's S1? S1 is 2 into 1 squared plus 8 into 1, and that gives us 10. What that means is sum of the first term. There's only one term, right? For the sum of the first one term. That's only one term, right? So that means the value of A therefore should be equal to 10. That's pretty straightforward, right? And then similarly, you could find S2 from this as well. Put n equal to 2, and that gives you 2 into 2 squared plus 8 into 2. And that simplifies to 8 plus 16, which is 24. Let me just check this again. Yeah, so that's okay. This is the sum of the first two terms. Now, what that means is, if the first term was 10, and we don't know what the second term is, their sum should equal 24, right? The first term is 10. The second term is 24. The sum of the first two terms is 24. So 10 plus the value of the second term, this should equal 24. And that gives us that the second term should be equal to 14. All right. And now, since we know it's an arithmetic progression and we know the first two terms, it's 10 and 14, and so on, we can figure out the difference from this. Difference is just 14 minus 10, and that gives you 4 as the result. So difference in this case is equal to 4. This could be another way of thinking about this, that you just input some values of n from that, try to make the sequence, try to write down the sequence, how it looks like, and then you can write down the values of A and n from that. All right, so this is another idea that you could use here. Let's look at part B. Now, the second part says, the first two terms of a GP are 64 and 48 respectively. Okay, so we know about the first two terms of a GP. Let's write that down here. So we have a geometric progression. We know the first term. The first term is 64, and the second term is 48. This is what we're given. And now it says, the first three terms of the GP are also the first term, the ninth term, and the nth term respectively of an AP. Find the value of n using this information. Now, which terms of the AP are we talking about? We're talking about the first term, the ninth term, and the nth term. Okay, so first term should be equal to 64. Ninth term should be equal to 48, right? And then the nth term should be equal to the third term of the GP. That's how they're related, right? Let's write them down here. So we have the first term of the GP, we have the second term of the GP. We don't know what the third term is. Let's keep it as it is for now. The second thing that we have is an AP. Which term of the AP are we talking about? Term 1. That is 64 as well. We know that. We know term 9. That is also the same as the GP. And yeah, so just leave it like this for now. 64 and 48, that's what is known. And we have the nth term then. We don't know what the value of n is. nth term of the AP, that is the same as the third term of the GP. This is how these three are related. Now remember what the term formulas look like for the AP and the GP. The term formula for a GP is AR raised to power n minus 1, and for an AP, it's A plus n minus 1 times the difference. Now, if you know the first two terms of the AP, of the GP, can you figure out the next term, the third term? That would just be AR squared, right? Can we figure that value out? AR square. We can figure out the ratio from this, right? That's pretty easy to figure out. From the first two terms, ratio would be second term divided by the first term. Let's actually evaluate this on the side here. A ratio would be equal to 48 over 64. What does that give us? That gives us 3 over 4. What about term 3 now? Can we find its value? Term 3 equals A, which is 64 into R, 3 over 4, raised to power n minus 1, that's 3 minus 1, which is 2. Evaluate this and you get the third term. Let's figure this out. 64 into 3 over 4 whole square. This turns out to be 36. So the third term of the GP therefore is 36. We know that. All right. Now we also know the first term and the ninth term of the AP. We know that the first term is supposed to be 64. The ninth term is supposed to be 48. The nth term is supposed to be 36. Now, how do we find the value of n from this? Now, we could think of using the nth term formula for the AP that looks like this: A plus n minus 1 times the difference. The value of Tn is 36. We could put that here. That's 36. Equals A. We know the value of A. The first term is 64. We could put that here. Plus n. We have to figure that out. Into times the difference. We don't know what the difference is. But can we figure out the difference? We could use the first two terms, and that is going to give us the difference. No, in fact, it's not the first two terms. It's the first term and the ninth term. Now we know the first term and the ninth term. We can use the term formula here to find the value of the difference. How does that work? Again, we use the same formula here. Tn equals A plus n minus 1 times the difference. Find the ninth term from this formula. A is 64 plus n minus 1. That's 9 minus 1. 8 times the difference. This is T9. Now the value of T9 is 48. So we have 48 equal to 64 plus 8D. And that gives us minus 16 equal to 8D. The value of the difference turns out to be minus 2. The value of the difference turns out to be minus 2. Now that we know the difference, we can just put this value here. And that would give us the corresponding value for n for this. 36 equals 64 plus n, which is unknown. We have to figure that out. Minus 1 times the difference. The difference now is minus 2. We just put that value here, and that's going to give us the result. 36 equals 64 minus 2n plus 2. And 2n equals 64 plus 2, which is 66 minus 36. That's 30. And the value of n turns out to be 15 from this. So we just used the nth term formula on the ninth term to find the difference, first of all, because we knew everything here apart from the difference in this formula. So we find the difference using this equation. And then once we know the difference and the first term, we can use the term formula to find the value of n, because we know that the nth term has 36 value. All right. So that was question number 32 from the worksheet. That was 5 marks. This is how you would approach this. All right, I hope that helps. In the next class, we will be discussing sum to infinity of a progression. And then we will start the next topic after that. All right, I'll see you again tomorrow. Allah Hafiz.